Let's dive right into this explainer, because back in October 2020, astrobiologists dropped an absolute bombshell that totally changes how we look at the night sky. They announced the discovery of 24 super habitable exoplanets. And get this, they're actually better suited for life than our very own Earth. But hey, the surprises aren't just light years away. Even our own solar system is hiding some incredible secrets. Take Jupiter's second largest moon, Callisto. For the longest time, people just wrote it off as this dead, rocky body. But then, in the 1990s, scientists proved it hides a massive subsurface ocean right beneath its icy crust. In fact, they suspect that if we could somehow block Jupiter's intense radiation, humans might easily breathe there. But today, we're zooming way past our local neighborhood to look at worlds that put Earth's habitability to absolute shame.
Now, you might be wondering, what exactly is the recipe here? How do astrobiologists look at a distant world and decide, yep, that one's actually superior to the blue marble we live on? Well, researchers like Dirk Schultz-Makuch don't just guess. They rely on a really strict checklist. If a planet actually checks these boxes, it's not just habitable, it's a super habitable world where life could thrive in ways we can literally barely imagine.
So, to be crowned super habitable, a planet basically has to follow 3 golden rules. First up, it has to sit at the absolute perfect distance from its host star, what we call the habitable zone, so that liquid water can pool on the surface. Second, it needs to be larger and more massive than Earth. Why? Well, a larger size means way more land area for life to spread out, and that greater mass gives it stronger gravity. That stronger gravity is exactly what holds on to a thicker, much more stable atmosphere close to the surface. And finally, rule number 3. The temperature should ideally be within about 5 degrees Celsius warmer or cooler than Earth's. Because if you think about it, right here on Earth, our greatest biodiversity is found in the warm, moist tropical zones. That's where microbes and complex life just absolutely thrive. Now, the absolutely crucial factor here is time. Our sun has a total lifespan of roughly 10 billion years, and it took nearly 4 billion of those just for complex life to evolve here. But red dwarf stars? They burn a lot slower. Even though they're cooler and less luminous, they can live anywhere from 20 to 70 billion years. Because of that massive lifespan, any life on a planet orbiting a red dwarf gets the spectacular 5 to 8 billion year ideal window to just perfectly evolve and adapt. By the time our sun eventually dies out, life on these distant worlds might literally just be hitting its prime. Let's kick off our interstellar tour with a few of the top-tier candidates we've found. First up is Newton B. This place is so rich in hydrocarbons and amino acids, the fundamental building blocks of life, that some scientists joke its perfection almost looks engineered by aliens. It's such a prime spot that back in 2017 and 2018, the METI organization actually beamed messages containing musical instruments and our cosmic address straight toward it. Then we have the TRAPPIST-1 system. This one is 39 light-years away and features 7 Earth-like planets practically packed together. Life there could easily be up to 3 billion years older than Earth. And finally, look at TOI 700D and E. These are Earth-sized, orbit their star in a matter of weeks, and boast these warmer temperatures that could theoretically support lush, Earth-like plant life. But here's where things get kinda wild. When we look closer at systems like TRAPPIST-1, we run into this fascinating phenomenon. A lot of these planets are what we call tidally locked. Basically, they don't spin on their axis the way Earth does. One side is permanently locked facing the star, just baking in endless daylight and intense heat, while the other side is cast in this frozen, never-ending night. But right down the middle, right on the equator of those two extremes, lies this magical twilight zone. It's a thin strip of real estate that perfectly balances the extreme hot and cold, creating this incredibly stable climate where life could comfortably set up shop. Okay, moving on to the heavyweights. These gravity giants have incredible specs, but they definitely come with a massive catch. Take KOI 5715.01. It is 8 times larger than Earth and sits at an incredibly comfortable 2.4 degrees cooler than our planet. Sounds great, right? But then, look at Kepler 452b. It's 1,800 light-years away in the Cygnus constellation, and it's 60% more massive than Earth. If you or I tried to walk on it, that intense gravity would wreak absolute havoc on our bodies. We're talking double the heart rate, double the blood pressure, and a drastically increased risk of strokes. Because of that crazy high atmospheric density and gravity, AI simulations actually predict that indigenous life there would likely evolve to fly. Imagine skies filled with creatures that look like giant airborne stingrays or bizarre balloon-sized organisms. Just a stone's throw away, 24 light-years away in the Scorpius constellation, sits Gliese 667c.
It's a tidally locked world orbiting a red dwarf in a triple star system. And man, this is a true world of extremes. The gravitational pull from its neighbors causes intense tidal heating, twisting its interior energy into thermal heat that violently erupts through volcanoes and geysers. Yet somehow, right in its twilight zone, the temperature rests at a balmy 27 degrees Celsius. That's essentially room temperature. Bizarrely enough, computer simulations suggest the specific zone might actually be inhabited by five-legged, dog-sized spider creatures that scurry under rocks to hunt for prey in the warm twilight. And honestly, this next one brilliantly illustrates just how bizarre our universe can be. Out in the Dorado constellation, 36.7 light-years away, there is a star 100 times brighter than our sun. Simulations suggest a planet nicknamed Actress A once orbited there before the star expanded and completely destroyed it. But get this, theorists suggest that if an advanced alien civilization lived on Actress A, they might have seen the catastrophe coming. They could have survived by building these massive, interconnected glass domes. Inside, they might not even function like individual humans anymore. They could function more like a massive, interconnected computer network, sharing resources, kind of like Earth's giant Armillaria ostoea, that sprawling fungal network that covers square kilometers in Oregon. Let's look even closer to home. Right next door, in our neighboring triple star system, there's an exoplanet circling Alpha Centauri c. It's theoretically much richer in oxygen than Earth, meaning it could support massive, giant-sized life forms running their own unique evolutionary race. But any human visitors looking to set up camp? Yeah, they would have to survive absolutely brutal seasonal swings. Because the planet is influenced by 3 different stars, the summers can soar to a blistering 60 degrees Celsius, and winters, they plummet all the way down to negative 90 degrees. We would for sure need some extreme, highly specialized equipment to ever call this place home.
Okay, let's bring it way back to our own backyard and see how this builds right here in our solar system, specifically with Saturn's moon Titan. The investigation into Titan is just a fantastic scientific saga. It all started back in 1944 when Gerard Cooper first discovered it actually had a unique, thick atmosphere. Decades later, on October 15, 1997, we launched the Cassini probe. Fast forward to 2005, Cassini finally arrives, penetrates Titan's atmosphere, and realizes this isn't just a dead rock. It detected these shocking, bizarre frequency signals. And no, it wasn't a glitch in the probe. The signals were being generated by the atmosphere itself, pointing straight to highly active, potentially life-supporting chemical cycles.
So unlike Earth, Titan's atmosphere is this wild, fascinating chemical cocktail of nitrogen, methane, ammonia, and hydrogen. But here is the mystery that totally baffled the Cassini scientists. Hydrogen is being formed high up in the atmosphere, but as it sinks down to the surface, it mysteriously vanishes. Now, on Earth, we actually have microbes that literally breathe and eat hydrogen. So could Titan have underground or liquid methane-dwelling microbes doing the exact same thing? Plus, Titan has volcanoes, but they don't erupt with hot lava. They are cryovolcanoes. They violently erupt freezing ammonia and methane, which incredibly are the exact substances you need to spark the origins of life.
Now, of course, Titan is not an easy place for us to just visit. Because its incredibly thick atmosphere acts like a giant shield, it blocks roughly 90% of the already distant sun's light. As a result, the surface temperature rests at a bone-chilling minus 179 degrees Celsius. To put that into perspective, humans can barely survive negative 30 degrees here on Earth without heavy gear. To even survive a minute on Titan, we would need highly specialized, actively heated technology just to take a single step outside. But here is the absolute most captivating takeaway from this explainer. 3.7 billion years ago, our very own Earth mirrored Titan's exact conditions. That's right, our planet was just a chaotic soup of hydrocarbons and phosphorus until a cosmic or electrical spark broke those elements down, forming RNA and eventually DNA. That's what kickstarted the journey from single-celled organisms all the way up to us. This means Titan, with its subsurface waters and its thick ethane-protected skies acting as a shield against cosmic radiation, is basically a primordial time capsule. It could be brewing life right now, just sitting there waiting for its own evolutionary spark.
So that brings us to the ultimate question. Will humanity ever actually colonize these super habitable alien worlds? I mean, sure, we have massive hurdles to overcome. We might need to use electrolysis to extract oxygen from Titan's underground oceans, or we might need to invent some crazy gravitational gear just to survive the crushing pressure of a place like Kepler 452b. We'd have to endure extreme temperatures and live in tiny twilight zones. But think about it. Human ingenuity has allowed us to survive everywhere, from the freezing Antarctica to the scorching Sahara. So, what do you think? Will we ever truly call these distant, extreme, yet remarkably super habitable worlds our home? It's an incredibly fascinating future to imagine. Thanks for joining me on this explainer, and keep looking up.